with the exciting process of urine formation. We're going to talk about the substances that are reabsorbed. Hello, where did you just go? Oh my goodness. There we go. Reabsorbed by tubular reabsorption. I don't know what happened to that last video. I was talking and then my computer must have taken a hit because the video was gone. The reabsorbed substances will include everything that's listed there, including miscellaneous vitamins. As water is reabsorbed, the substances that are in the filtrate become more and more concentrated. And that should make sense. There are tons of videos about the countercurrent multiplier on YouTube, on the internet, and this is what you need to know for the purposes of this class. We're talking about the loop of Henle at this point, the nephron loop. This is the countercurrent multiplier is going to be associated with the nephron loop. And the purpose of the countercurrent multiplier is that we balance the concentration of ions, particularly sodium, and the level of water within the kidneys and within the circulatory system. So that's the overall goal of the countercurrent multiplier. How does that happen? You'll see that the filtrate is going to move down the descending limb of the loop of Henle and then up the ascending limb. So what happens is this. Ions, sodium, potassium, chloride, some others, but mainly sodium. We're interested in sodium. We're also interested in the other ones, but the main player in this case will be the sodium. So sodium and the other ions are going to leave the ascending limb. As sodium leaves the loop of Henle, water is going to follow sodium. So sodium will end up becoming more concentrated in the ascending limb, and we know that we're always striving for equal concentrations on either side of a membrane. So more sodium will leave. When the sodium leaves, water leaves. More sodium will leave, more water will leave. More sodium will leave, more water will leave. More sodium will leave, more water will leave. You get the picture. So in essence, what happens is the more salt that is pulled out of the ascending limb of the loop of Henle, the saltier the extracellular fluid is around that area. And the saltier the water is, the solution is, I should say, the higher the concentration of salt, the more water will be pulled out of the descending limb. And if you understand that, that is exactly what you need to know for this class. Encourage you to have at it and watch that video and be amazed and awed at how great a job our nephron loop does in helping maintain that those concentrations and that osmolarity. Go forth if you like. Now, tubular secretion occurs mostly in the distal convoluted tubule. That's what DCT stands for. It is the process in which substances that are not supposed to be in your circulatory system get moved into the distal convoluted tubule. So you'll remember that anything that is too big in the glomerulus can't get through those filtration slits and get picked up by the Bowman's capsule. So you have a whole bunch of stuff, drugs, toxins, various acids, some ions, etc., can't get through, and you need to get rid of them. So how do we do that? This is how we do it. So again, the substances that are not supposed to be there, or ones that we have a very high concentration of, too high a concentration of, will get moved from the blood into the distal convoluted tubule, and therefore will spill out into urine. There will be selective reabsorption of sodium and calcium from tubular fluid, and there will also be selective resorption of water, which helps concentrate tubular fluid. So how do we regulate concentration and volume of urine? Our friend ADH. You'll remember that ADH is going to promote the reabsorption of water through our friends, the collecting ducts. It is a negative feedback mechanism, and it is going to help prevent dehydration. So if there is no ADH present, the collecting duct will not be permeable to water, and you will have a large volume of urine. When you have ADH available and working, the collecting duct becomes permeable to water, and you will have a smaller volume of more concentrated urine. Now, remember when we talked about the anatomy of a hangover? Remember that alcohol really likes the receptors for ADH? And that is why when you drink excessively, you end up urinating a lot, because the receptors are already taken by alcohol, and therefore you will end up expelling a large volume of unconcentrated urine. Let's stop here so you can cogitate about this, and we'll wrap up in the next video.